Okay, the next thing we're going to take a look at when it comes to graphs is how to sketch them very quickly. And if we take a look at the graph from the previous problem, you can see there's kind of a they kind of go to 360. Sometimes you get a lot of different cycles in 360 because you have a short period. Um, you might have a longer period, and if you have a period that's over 360 degrees, you usually make your theta axis longer. That way you can at least, you always want to be able to see at least one period. If you see more than one period, that's not that big of a problem. We usually, if we're going to see more than one, we don't go past 360. But if let's say the period was 720, I'd want to make sure I stretch that out the whole way to show you. But it's really valuable here. I'll highlight them in pink to find out when it crosses the theta axis. So you can see that I got all these little points here. I'm highlighting them in pink. Those are all the spots where it crosses the axis. Because if we know that it starts, like this was a cosine function, it starts at the top, then I know where I'm going to start at the top, where it's going to cross, where it's going to cross again. So it's got to be go all the way down in between those points. So alternating between those points is for the maximum and the minimum, and back and forth and back and forth. So how do we find those points? Well, first we got this nice little table here. It's on page 838. But basically, the idea is um, you're going to uh, use the b value, which we use to calculate the period, and we're going to choose the right option here. It was cosine of 4 cosine of 3 theta, so our b value was 3, right? So I'm going to plug it into this formula, and you can see it's 1/4 times 360 divided by the b value. Notice not absolute value this time. So it's 1/4 of 120. That would be 30, comma, 0. That's our first point. And if you can see here, that very first spot where it crosses the theta axis is actually 30, comma, 0. For the next one, we would do 3/4 times 360 divided by uh, 3. So 360, wait a second, we divide those out there, those 3's go away. 360 divided by 4 is going to be 90, comma, 0. And you can see that is our second pink value right there, and that is 90, comma, 0. And with those two pieces together, see we start at the top at the maximum, go down through that point, down to the minimum, which we know from the amplitude, and then back on up through that other pink point, that second pink point there, to the top. So that's going to describe your your theta intercepts for the first cycle, right? It's only for the first cycle. But then once you do that, you figure out the pattern of the cycle, and then you can continue onwards because the pattern always repeats. A really important thing here to remember, just like we mentioned before, like for sine, it's going to go through 0, 0. It's going to go through the origin. The second one is 1/2 times 360 over the b value. But remember, if you're working with radians, you change that 360 out for 2 pi, and you could actually even simplify that down. And you could simplify these down for radians if you wanted to, but you just plug in 2 pi, figure it out, and go from there. Um, so just keep that in mind when you're working on them. Um, right now, I think we'll mostly be dealing with these functions in degrees, but it's always good to think about what it would look like in radians because that's another measurement of angles. All right, let's graph a couple. Let's graph a couple. So we're going to graph two different things. We got y equals 2 times the sine of theta. So when I'm looking at this, I see an amplitude of 2. Because the absolute value of 2 is 2. So amplitude is 2. there's no change in the period, so I know the period is 360, which means for my table, like those highlighting those important points there, I know because it's sine, it's going through 0, 0. I also know it's 1/2 times 360 over 1, comma 0. Well, that's just 180, comma 0. And then I do that again with the next one, um, just 360 divided by the period, which is 1, comma 0, which is going to be 360, comma 0. All right, so there's my 3 points. I'll underline them. Those are 3 points. I've got an amplitude of 2 and a period of 360. So I need to draw myself a table. Sorry, a chart here. Now you can see I switched back today to doing this on graph paper, because it's really nice on these to have graph paper. So all I have to do is decide how many blocks do I want to be equal to basically one of these divisors. Like I see 180 and 360, I'm going to divide that up into quarters even and go every 2 is going to be 90 degrees. This is 180, this is 270, and this is 360. Okay, now for amplitude, the nice thing about that is because there's just a top and a bottom at this point, because we're not transforming them up and down at all yet, I basically just need to choose something to be my 2. Let's have that be a 2 up there, so that's a 1, and that's a 1, and that would be a -2. Now I plot my points. I'll do it in blue. 0, 0. 180, 0. Which means in between those two, because the sine function goes up, I must be at the top there. And then the next part of the period is 360, and in between those, I must be at the bottom. Smooth out the line. And there we go. There's our graph of y equals 2 sine theta. Okay. Now let's do the same thing for cosine. Let me get a little bit more space here. This one, you can see there's no change in the amplitude, so the amplitude is 1. Not much to change there, but the period has changed. So 360 divided by the absolute value of 4 is 90. So now our period is 90. And if you remember from our little chart, we actually are going to use this 360 divided by 4 in our little calculation. So I have 1/4 times 360 divided by 4. So I have 1/4 of 90. 1/4 of 90. Well, half of 90 is 45. So does that mean 22.5? Is that what I'm working with here? 20. Let me calculate that out real quick just to make sure I got that right. 360 divided by 4 is 90. Divided by 4 again. And we've got ourselves 22.5. So our first intercept is going to be 22.5, comma 0. Our second intercept is going to be 3/4 of that. So really all I have to do is multiply that one by 3, but 3/4 times 90. So 3 times 90. 3 times 90 divided by 4, and we get 67.5, comma 0. So now you can see we've got slightly not nice numbers, but that's okay. When I do these, I expect sometimes that the periods are going to be odd. So now all I have to do is decide, when I was doing this in my head, I had 90, I divided it in half and got 45, and then divided it in half again, and I got 22.5. So if I make every 2 lines 45 degrees, that'd be 135, and let's do 180 there. If I make the lines every 2 lines on the theta axis 45 degrees, that means every line is 22.5 degrees. Okay, 22.50, boom. 67.5, that's right in the middle here. So it looks to me like I'm doing every other mark there. Now you can see here, because it's a tighter period, I'm putting more cycles into it. Cosine starts at the maximum, so I need to write the maximum on here. Let's go ahead. It doesn't really matter, but I'll just make that a 1 and a negative 1 there. Remember, the amplitude hadn't been changed at all. So I start at the top, and then I go to the bottom. So I go down, and I curve back up. Get to the top at the 90, and back down, and bottom at 135. And then top at the 180, and then back down. And there we go. That is my graph of y equals, cosine of 4 theta.